A ball is thrown straight up at an initial speed of 30 meters per second. How high does the ball go? Not given a whole lot here, are we? We have VI is equal to 30 meters per second. Now, what's not given, except that we're on the planet Earth, and if you throw a ball up, it is only subject to one force once it leaves your hand, and that's gravity. And that will cause an acceleration of negative g. So that's in the down direction because gravity pulls everybody down. And then at the maximum height, the velocity will be 0 as it switches from a positive velocity going up to a negative velocity going down. So isn't that amazing? These words all give you this information without saying it. And the only number they're giving you is 30 meters per second. Let's solve it. We're actually going to use both the first and second kinematics equation. As you get more experienced in physics, and frankly we teach you some more, there's a third kinematics equation that combines the first two, and it would solve this problem a lot quicker. But we don't know that yet, so we're going to have to do it the hard way. We start with the first kinematics equation. Vf is equal to Vi plus At. And what's the acceleration? Well, it's due to gravity right here. So we substitute in negative g for A, and actually we go one step further because what's g? It's going to be negative 10 meters per second squared. So we now have Vi minus 10t. We're trying to solve for time here, and I'll show you why in a second. So we move 10t to the one side on the left by adding a positive 10t to both sides and subtracting Vf from both sides. We kind of did two steps in one there. So 10t is Vi minus Vf. So if you'd like, take time and just put in the medium stage we did there. Tell you what, let's do it. So we have Vf is equal to Vi minus 10t. We'll add 10t to both sides, right? Because whatever you do to the right, you have to do to the left. So we now have Vf plus 10t equals Vi. And now we subtract Vf from both sides because we'd like to isolate 10t. And when we do that, we get 10t is equal to Vi minus Vf, just like we showed right there. One more step, we will undo the 10 times the t by dividing both sides by 10. We have our final expression here. T is equal to Vi minus Vf over 10. And we put the seconds there so we know we get the right units. Substitute the initial velocity of 30, final of 0, from our givens over here, and we get time is equal to 3 seconds. We now want to find out how high it goes. That is the second kinematics equation, where this term here, you're going to say, where did that 5t squared come from? Well, second kinematics is Vit plus 1/2 At squared. What is A equal to? A is equal to minus 10, right? It's minus g, which is then minus 10. So we substitute that in, Vit plus 1/2 times a minus 10 t squared, and that gives us the minus 5t squared. Substitute in our values, initial velocity of 30, 3 seconds, which we found over here in the first part of our problem, minus 5 times 3 seconds squared. Please be sure to square that t squared. That's a very common error. And then finally, we get delta y is 45 meters.